this will be sin phi minus 5 minus theta by 2 will be cancelled out, here 2 will be cancelled out, and within mod we can write this as cos phi minus theta by 2. Okay, that will be your distance. Hi, welcome back to our channel AnganaStudyCenter. In previous class we have done up to exercise 9.3. Today we will solve the miscellaneous example and exercise. Okay, the miscellaneous exercise we have divided this part in two different parts. Okay, today we will solve up to exercise 9 and practice all of the example of miscellaneous. Okay, so let's start our class. Then look at this question. If the lines 2x plus y minus 3 equal to 0 and 5x plus ky minus 3 equal to 0 and 3x minus y minus 2 equal to 0 are concurrent, find the value of k. Okay, we first find the intersecting point of these two lines. Okay, so if they are concurrent, then that point should satisfy this equation. Okay, so just see here 2x plus y minus 3 equal to 0, this is equation 1. 5x plus ky minus 3 equal to 0, this is equation 2, and 3x minus y minus 2 equal to 0, this is equation 3. Okay, now solving 1 and 3, solving 1 and 3. Okay, we get what we will get here. Just multiply this with 3, sorry, just write here 2x plus y minus 3 equal to 0, or here 3x minus y minus 2 equal to 0. Just adding this we get plus y minus y will be cancelled out, and here 5x minus 5 equal to 0, x equal to 1. Now by putting the value of x in 1 we get y equal to minus 2x plus 3. So here we get minus 2 plus 3, that means 1. So the point of intersection is 1, 1. Okay, so as these three lines are concurrent, so this line should be passed through this. So therefore we have 5 into 1 plus k into 1 minus 3 equal to 0, or k equal to minus 2. Okay, this is the value of k. Clear? Find the distance of the line 4x minus y equal to 0 from the point 4.1. Okay, measured along the line making an angle 135 degree with the positive direction of x. Here is a line which makes 135 degree angle with the positive direction of x. That means the inclination of the line is 135. So we first find the equation of the line. Okay, that line should be passed through 4, 1. Okay, so the equation of the line is here, as is passed through 4.4, 1. So we know y minus y1 equal to 1. Here m equal to tan theta, we write tan theta, x minus 4. Okay, or y minus 1 equal to tan theta equal to tan 135 into x minus 4, or y minus 1 tan 135 equal to tan 90 plus 45 equal to x minus 4, or y minus 1 equal to tan 90 plus 45 equal to minus cot 45, that means minus 1 into x minus 4. Okay, so if we moving this part to this end, we get y minus 1 plus x minus 4 equal to 0, or x plus y minus 5 equal to 0. So this is the equation of the line, and we have one line also, 4x minus y equal to 0. This is the equation 2. Now solving these two, we get y will be cancelled out, 5x equal to 5, or x equal to 1. So now we get therefore y equal to 4. Okay, so now we get a point 1, 4. Okay, so now we have 2 points. Let p equal to 4, 1, and here we get this point q equal to 1, 4. So the distance between this point will be your answer. Okay, so the distance between p and q is root over x2 minus x1 mean 1 minus 4 whole square plus y2 minus y1 4 minus 1 whole square, that means minus 3 whole square, that means 9, plus here 3 square equal to 9 equal to root 18. Okay, that means 3 root 2 unit. Okay, clear? Now look at this question. Assuming the straight line works as a plane mirror. Okay, for a point, find the image of point 1, 2 in the line x minus 3y plus 4. So just look at in this here, let this is the point P, okay, 1 comma 2. So if this is a mirror, we know the reflection should be the same distance, that means here let x, so this Px and this is the Q point, we should find the coordinate of Q, okay. So Px equal to Qx, as this is the mirror, that means this is the straight line, x minus 3y plus 4 equal to 0, okay. So this is the bisector. If we consider this, so PQ is the bisector of this, so bisector should be perpendicular with this. So the given line x minus 3y plus 4 equal to 0. From here we can write 3y equal to x plus 4 or y equal to 1 by 3x plus 4 by 3. Okay, this is equation 1. So the slope of this line is 1 by 3. Okay, so the slope of PQ, as PQ is the bisector, so the multiplication of their slope is minus 1. So PQ equal to minus 3. Okay. So the equation of the line passing through 1, 2 and HK is y minus y1 mean 2 equal to y2 k minus 2 divided by h minus 1 into x minus 1. Okay. So this is the slope of this line, this is equation 2. Okay. So therefore k minus 2 divided by h minus 1 equal to minus 3, we get this, or k minus 2 equal to minus 3h plus 3, or 3h plus k minus 5 equal to 0. This is equation 3. Now x is the midpoint of PQ. Okay, as Px equal to Qx, Px equal to Qx. So therefore x is midpoint, and midpoint is on this line. So midpoint will be 1 plus h by 2, 2 plus k by 2. Okay, this midpoint should be on x minus 3y plus 4 equal to 0. So we can write this as 1 plus h by 2 minus 3 into 2 plus k by 2 plus 4 equal to 0, or 1 plus h minus 6 minus 3k plus 8 equal to 0, or h minus 3k plus 3 equal to 0. This is equation 4. Now solving these two, that means 3 and 4, just multiply this with 3 and here we get 3h plus k minus 5 equal to 0, and here 3h minus 9k plus 9 equal to 0. So we have, if we minus this plus minus, this will be cancelled out, and here will be 10k equal to 14, or k equal to 7 by 5. Therefore h equal to, just putting here the value of k, we get h. So therefore 3h equal to minus k plus 5, that means 5 minus 7 by 5, 25 minus 7, that means 18 divided by 5. Therefore h equal to 6 by 5. So the mirror point is 6 by 5 comma 7 by 5. Okay. Then look at this question. So that the area of the triangle formed by the line y is equal to m1x plus c1, y equal to m2x plus c2, and x equal to 0 is c1 minus c2 whole square divided by 2 mod of m1 m2. So just look, if these lines are this type, okay, this is y is equal to m1 x c1, y equal to m2x c2, and x equal to 0. Okay, so the point of intersection will be the vertex of the triangle. Okay, so we have y is equal to m1x plus c1, this is equation 1, y equal to m2x plus c2, this is equation 2, and x equal to 0, this is equation 3. So solving 1 and 3, we get x equal to 0, that means y equal to c1. Okay, so y equal to c1, therefore point of intersection 0 comma c1. Okay, solving 2 and 3, we get y equal to C2. Therefore, point of intersection will be 0 comma C2. Okay, and solving 1 and 2, we get m1 minus m2 into x plus c1 minus c2 equal to 0, or x equal to c2 minus c1 divided by m1 minus m2. So, the point of intersection is c2 minus c1 divided by m1 minus m2, comma, here y will be, just put the value of x here. So, we get y equal to m1 c2 minus m1 c1 divided by m1 minus m2 plus of m1 c1 minus m2 c1. Okay. So, here just look, this will be cancelled out and we have m1 c2 minus m2 c1 divided by m1 minus m2. So, this point of intersection will be m1 c2 minus m2 c1 divided by m1 minus m2. So, the area of the triangle will be, half of mod x1, that means 0. So, the term will be 0, then x2 will be 0, term will be 0, then x3, that means c2 minus c1 divided by m1 minus m2, x3 into y1 minus y2, y1 c1, y2 means c2. Okay. So, that will be half of, here if we write this c1 minus c2 and minus here within mod, and here also c1 minus c2. Okay. So, m1 minus m2. So, the minus will be plus as is come out from mod. So, there will be c1 minus c2 whole square divided by 2 of mod m1 minus m2. Okay, proved. Clear? Then look at this question. A line is such that each segment between the line 5x minus y plus 4 equal to 0 and 3x plus 4y minus 4 equal to 0 is bisected. Okay, at 1, 3. So, just look, let these are the line. Okay, this is 5x minus y plus 4 equal to 0 and this is 3x plus 4y minus 4 equal to 0, and the segment is, let this is P, this is Q. Okay, let this is the coordinate is alpha 1 beta 1 and this is coordinate alpha 2 beta 2, and the bisect, that means this is the midpoint, this is 1, 3. So, we will find the equation of PQ. Okay, as alpha 1 beta 1 on the line 5x minus y plus 4 equal to 0. So, we can write 5 alpha 1 minus beta 1 plus 4 equal to 0, equation 1. Okay, and alpha 2 beta 2 on this line. So, we can write 3 alpha 2 plus 4 beta 2 minus 4 equal to 0. Okay, this is equation 2, and we have, as this is the midpoint of PQ. So, alpha 1 plus alpha 2 divided by 2 equal to 1, or alpha 1 plus alpha 2 equal to 2, and beta 1 plus beta 2 divided by 2 equal to 3, or beta 1 plus beta 2 equal to 6. Okay, so we get up to this. Okay, now we find the equation of the line passing through alpha 1 beta 1 and alpha 2 beta 2. So, the equation of the line passing through P and Q point is y minus beta 1 equal to beta 2 minus beta 1 divided by alpha 2 minus alpha 1 x minus alpha 1. Okay, this is the equation 3. Okay, now from these two we should replace alpha 2 and beta 2 by beta 1 alpha 1. Okay, so from 2 we can write 3 alpha 2 equal to 2 minus alpha 1, 2 minus alpha 1, and beta 2 equal to 4 into beta 2 equal to 6 minus beta 1 minus 4 equal to 0. So, this will be 6 minus 3 alpha 1 plus 24 minus 4 beta 1 minus 4 equal to 0. Okay, or here 3 alpha 1 minus 3 alpha 1 plus 30 minus 4 equal to 26 minus 4 beta 1 equal to 0. Okay, and or this can be written 3 alpha 1 plus 4 beta 1 minus 26 equal to 0. This is the equation 4. Okay. Now solving this 1 and 4, we get here just multiply with 4. We get 20 alpha 1 minus 4 beta 1 plus 16 equal to 0. Just solving this, just adding this, we get 23 alpha 1 equal minus 10 equal to 0, or alpha 1 equal to 10 by 23. So we get alpha 1. Okay, and just putting the alpha 1 in equation 1, we get beta 1 equal to 5 into alpha 1, that means 50 by 23 plus 4, that means 50 plus 92 by 23, that means 142 by 23. We get alpha 1 and beta 1. So, therefore, alpha 2 equal to 2 minus alpha 1, that means 10 by 23, that means 46 minus 10, that means 36 by 23, and beta 2 equal to 6 minus beta 1, that means 6 minus 142 by 23, that means 18. Okay, so that will be minus 4 by 23. So now putting this value to this equation 3, we get the equation of the line. Therefore the equation will be y minus beta 1 equal to, here beta 1 142 by 23 equal to beta 2 mean minus 4 by 23 minus beta 1 equal to 142 23 divided by alpha 2 equal to 36 by 23, alpha 1 equal to 10 by 23, x minus alpha 1 equal to 10 by 23. Just solving this equation, you get the equation of the straight line. Okay, clear? Just look at this question. So that the path of the moving point such that its distance from two lines 3x minus 2y equal to 5 and 3x plus 2y equal to 5 are equal is a straight line. Okay, so let the point P H comma K. Okay, so the distance from this point P from this line and from this line are equal. So therefore we can write mod of 3h minus 2k minus 5 divided by root of 3 square plus minus 2 square, that means 4 equal to, here from this line the distance will be mod of 3h plus 2k minus 5 divided by root of 3 square plus 2 square. Okay, so from this is the number 1. From this two conditions will be happen. So case 1 3h minus 2k minus 5 divided by root of 9 plus 4 equal to, both are plus. Okay, so 3h plus 2k minus 5 divided by root 9 plus 4, or from here we can write minus 2k minus 5 equal to 2k minus 5, or 4k equal to 0, or k equal to 0. Okay, and case 2 3h minus 2k minus 5 divided by root 9 plus 4 equal to minus of 3h minus 2k plus 5 divided by root 9 plus 4, or from here we can write 6h 2k will be cancelled out and here will be 10, or h equal to 10 by 6, that means 5 by 3. Okay, so this point satisfy here k equal to 0, that means y equal to 0, and here h equal to 5 by 3, that means x equal to 5 by 3, which are the straight line. So the point P satisfy y equal to 0 and x equal to 5 by 3, which are straight line. So the path is straight line. Okay, clear? Now we will solve the miscellaneous example. Today we will solve up to example exercise 9. Okay, in next part we will do the rest part. Okay, now just look at this question. Find the value of k for which the line k minus 3x minus 4 minus k square into y plus k square minus 7k plus 6 equal to 0 is parallel to x axis. So for the question 1, when parallel to x axis, that means the equation of a straight line when he is parallel to x axis equal to y equal to 0. Okay, so here this part will be 0. So from this line, if this line is parallel to x axis, so this part is 0, this part is 0, and this is the 0 part. So therefore k minus 3 equal to 0 when parallel to x axis. Okay, so therefore just calculate k equal to 3. And for this 2, similarly here when parallel to y axis, that means this part is not, and this is the 0 part. So if this is the 0 part, so 4 minus k square equal to 0 when parallel to y axis. So or k equal to plus minus 2. Okay, and for this 3 passing through origin, if this line passing through origin, just put here in the place of x 0 and y equal to 0, as the coordinate of origin is 0, 0. So we have, if we put x 0 and y 0, so we have this part only. So when passing through 0, 0, therefore k square minus 7k plus 6 equal to 0, or k square minus 6k minus k plus 6 equal to 0, or if we factor this, k into k minus 6 minus 1 into k minus 6 equal to 0, therefore either k equal to 6 or k equal to 1. Okay, then look at this question. Find the equation of the lines which cut off intercept on the axis whose sum and product are 1 and minus 6 respectively. Okay, so the basic intercept form of a straight line x by a plus y by b equal to 1, where the x intercept is a and y intercept is b. Okay, so the equation of the basic equation of the line is x by a plus y by b equal to 1. Here a is the x intercept and y is the b intercept. Okay, a equal to x intercept and b equal to y intercept. Okay, so here just look, sum and product, that means the intercept sum. Therefore a plus b equal to 1 and ab equal to minus 6. Okay, so this is the 1 and this is the 2, equation 2. Okay, now therefore we can write a minus b whole square equal to a plus b whole square minus 4ab. That means just putting this value 1 square, that means 1 minus 4 into minus 6. Okay, so we have 1 plus 24, that means 25. Therefore a minus b equal to plus minus 5. Okay, so when a minus b equal to plus 5, okay, and this is equation 3, and when a minus b equal to minus 5, this is equation 4. Now solving 1 and 3, okay, solving 1 and 3, we get 2a equal to 6 or a equal to 3. Therefore b equal to minus 2. Okay, and when a minus b equal to minus 5, that means if we solving 1 and 4, we get 2a equal to minus 4. That means therefore a equal to minus 2. Therefore b equal to 1 minus a, 1 minus a, that means plus 2, that means 3. So the equation of the line will be x by a, that means 3, plus y by minus 2 equal to 1, and here x by a equal to minus 2 and y by 3 equal to 1, or y by 3 minus x by 2 equal to 1, or this can be 2y minus 3x equal to 6, or 3x minus 2y plus 6 equal to 0. This is the one equation, and this is x by 3 minus y by 2 equal to 1, or 2x minus 3y minus 6 equal to 0. Okay, this is one equation and this is the another equation. Then look at this question. What are the points on y axis whose distance from this line is 40 units? So we first let the coordinate of the point, as this is y axis, so let the points are 0, 8. Okay, as this is on y axis, so this part will be 0. Okay, so now distance of this point from to this line. Okay, so this line, that means x by 3 plus y by 4 equal to 1. just simplify this. 4x plus 3y minus 12 equal to 0. This is the line. Okay, given line. So the distance d equal to mod of 4 into 0 plus 3 into h minus 12 divided by root 16 plus 9. That means mod of 3h minus 12 divided by root 25. Okay. So therefore, according to the condition, we have mod of 3h minus 12 divided by 5 equal to root 25 equal to 4. So there is two case. Case 1, 3h minus 12 divided by 5 equal to 4, or h equal to 32 by 3. Okay. And case 2, 3h minus 3h plus 12 divided by 5 equal to 4, or minus 3h equal to 20 minus 12, that means 8, or h equal to minus 8 by 3. So the point will be 0, 32 by 3 and 0, minus 8 by 3. Okay, clear? Now look at this question. Find the perpendicular distance from the origin to the line joining points this and this. So we first find the line passing through this point. The equation will be, the equation is y minus y1 equal to sin theta equal to y2 minus y1, that means sin phi minus sin theta divided by cos phi minus cos theta into x minus cos theta. Okay. Just cross multiply, we have cos phi minus cos theta into y minus cos phi sin theta plus cos theta sin theta, okay, equal to x of sin phi minus sin theta, and here minus cos theta into sin phi plus sin theta cos phi. Okay. So just moving here, we get y cos phi minus cos theta minus x sin phi minus sin theta. Okay. And here it will be if we cos phi sin theta and cos phi sin theta, and this will be sin theta cos theta plus sin theta cos theta. Okay. So these two part will be cancelled out, and here we have plus of cos theta sin phi minus cos phi sin theta, okay, equal to 0, or this can be written as x sin phi minus sin theta plus y cos theta minus cos phi plus sin theta cos phi minus cos theta sin phi equal to 0. Okay. Now, or this can be written as x sin phi minus sin theta plus y cos theta minus cos phi plus, this is the equation of, if we common minus, sin phi minus theta equal to 0. Okay. So the distance, perpendicular distance from origin, so therefore I moving here, the distance d equal to mod of here this, that means this will be 0 and this will be 0. So we have minus sin phi minus theta, okay, divided by root within mod, obviously this square and this square, that means sin square phi cos square phi, that will be 1, sin square theta cos square theta, that will be 1, minus 2 sin theta sin phi, 2 sin theta sin phi, and here minus 2 cos theta cos phi. Okay. So mod of minus sin phi minus theta divided by here 2 minus 2 into phi minus theta, okay, within mod. So here minus sin phi minus theta divided by, if we common 2, we have 1 minus cos phi minus theta, okay, within mod. So this will be mod minus sin phi minus theta divided by 2 into, this is the 2 of sin square phi minus theta by 2, okay, and this upper portion will be 2 sin phi minus theta by 2 cos phi minus theta by 2, and here 4, sorry, this is the sin square, 4 sin square phi minus theta by 2, okay, within mod. Sorry, this is within root, this is also within root, this is also within root, this is also within root. So this will be sin phi minus phi minus theta by 2 will be cancelled out, here 2 will be cancelled out, and within mod we can write this as cos phi minus theta by 2, okay, that will be your distance. Then look at this question, find the equation of the line parallel to y axis and drawn through the point of intersection the line x minus 7y plus 5 equal to 0 and 3x plus y equal to 0. So we should first find the point of intersection of these two lines. Here x minus 7y plus 5 equal to 0 and 3x plus y equal to 0. This is equation 1 and this is equation 2. Just multiply this with 3. We get now solving 1 and 2. So 3x minus 21y plus 15 equal to 0, and here 3x plus y equal to 0. Just minus this, we have, this will be cancelled out, here we have 22y equal to minus 15, or y equal to 15 by 22, okay. So we find out x, therefore x equal to 7 into 15 by 22 minus 5, okay. So we have minus 5 by 22, okay. So we have find the point of intersection xy, that means minus 5 by 22 comma 15 by 22. So we find the equation of the line parallel to y axis. So therefore the equation of the line parallel to y axis is x equal to c1, okay. Here just putting the value of x, that means 5 by minus 5 by 22 equal to c1. Therefore the equation is x equal to minus 5 by 22, that means 22x plus 5 equal to 0 is the required equation of the straight line, okay. Now look at this question, find the equation of the line drawn perpendicular to the line x by 4 plus y by 6 equal to 1 through the point when it meets at y axis. So given line is x by 4 plus y by 6 equal to 1. So here the point when it meets y axis, here this line meets y axis at, that means the y intercept, that means 0 comma 6, okay. So the equal line passing through this point, and that equal line is perpendicular to this. So from this we have the LCM of 4 6 equal to 2 3 12 equal to 3x plus 2y equal to 1, or 3x plus 2y equal to 12, or 2y equal to minus 3x plus 12, or y equal to minus 3 by 2x plus 6, okay. This is the equation of the line. So the slope of line is minus 3 by 2, as the equal line is perpendicular to this line. So the slope will be, the slope of required line is minus 1 divided by minus 3 by 2, that means 2 by 3, okay. So the equation of the equal line y minus, here y1 equal to 6 equal to 2 by 3 into x minus 0, or 3y minus 18 minus 2x equal to 0, or 2x minus 3y plus 18 equal to 0. That will be your answer, okay. Just look at this question, find the area of the triangle formed by the line y minus x equal to 0, x plus y equal to 0, and x minus k equal to 0. This type of example we have done already, okay. So y minus x equal to 0, this is equation 1, x plus y equal to 0, this is equation 2, and x minus k equal to 0, this is equation 3. Now solving 1 and 2, solving 1 and 2, we get the intersecting point, and intersecting point will be the vertex of triangle. Okay, so 1 and 2 we have 2y equal to 0, that means y equal to 0 and x equal to 0. Okay, solving 1 and 3, 1 and 3 we have 1, and if we solve 1 and 3, y equal to k and x equal to k. Okay, and solving 2 and 3, we have, if we solve 2 and 3 and minus this, y plus k, y equal to minus k and x equal to k. Okay, so the vertices of triangle is 0 0, k k and k minus k. So the area will be half of mod x1, that means this part will be 0 and x2 equal to k, x2 y3 minus y1, that means y3 equal to minus k minus y1 equal to 0 plus x2 and x3, that means k, y1 that means 0 minus y2 k square unit. So half of mod, here this is minus k square and this is also minus k square. So half of minus of 2 k square. Okay, and within mod minus 2 k square will be plus k square. If we mod will remove, so 2 k square divided by 2, that means k square square unit. Okay, find the value of p so that the three lines 3x plus y minus 2 equal to 0, px plus 2y minus 3 equal to 0 and 2x minus y minus 3 equal to 0 intersect at a point. So here three lines intersect each other. Okay, so the common point of intersection, that is p. Okay, so here the given line are 3x plus y minus 2 equal to 0, this is equation 1, px plus 2y minus 3 equal to 0, this is equation 2, and 2x minus y minus 3 equal to 0, this is equation 3. Okay, now if we solve these 1 and 3, we get the common intersecting point. The solving 1 and 3, we get 5x minus 5 equal to 0 or x equal to 1 and y equal to minus 3x plus 2, that means minus 3 plus 2, that means minus 1. Okay, so the intersecting point of line 1 and 3 is here 1 comma minus 1, and three lines are intersect each other. So in a point P, so this point must satisfy this equation, or this line is passing through minus 1. So therefore we have P into 1 plus 2 into minus 1 minus 3 equal to 0, or P minus 5 equal to 0, or P equal to 5. Okay, this is the value of P. If three lines equation are y equal to m1x plus c1, y equal to m2x plus c2 and y equal to m3x plus c3 are concurrent, three lines are concurrent, that means the intersecting point, if there is an intersecting point between these two, as they are concurrent, so the intersecting point should be on the third line. In this way we should solve this. Okay, so the equation of the lines are y is equal to m1x plus c1, this is equation 1, y equal to m2x plus c2, this is equation 2, and y equal to m3x plus c3, this is equation 3. Now we do this 2, solving 1 and 2, we have m1 minus m2 into x equal to c2 minus c1, or x equal to c2 minus c1 divided by m1 minus m2. Now putting this value of x to 1, therefore y equal to m1 c2 minus m1 c1 divided by m1 minus m2 here plus m1 c1 minus M2 C1. Okay. So this term will be cancelled out. So here is M1 C2 minus M2 C1 divided by M1 M2. So this is the intersecting point of 1 and 2. Here, as these are concurrent, so this point should be on this line, that means the third line. So as these three lines are concurrent, therefore the point C2 minus C1 divided by M1 minus M2 comma M1 C2 minus M2 C1 divided by M1 minus M2 satisfy equation 3. Okay. Therefore we have M1 C2 minus M2 C1 divided by M1 minus M2 equal to M3 into C2 minus C1 divided by M1 minus M2 plus C3 into M1 minus M2. Okay. So this term will be cancelled out. So we have M1 C2 minus M2 C1 minus M3 C2 minus C1 minus M1 C3 plus C3 M2 equal to 0. Okay. Or now from this, if we common M1, therefore this and this C2 minus C3, okay, and M2 part, that means plus M2 C3 minus C1, and here if we common minus, this will be plus M3 C1 minus C2 equal to 0. Proved. Okay. So that's all for today's class. We have covered up to exercise 9 of miscellaneous example of this chapter. Okay. In the next class, we will solve the next problem, that means from exercise 10 to 23. Okay. If you don't watch the previous videos of our classes of straight line, please watch the videos first and then do the all example and practice all these things we have covered in this class. If you like this video, please press the like button and subscribe our channel and share with your friends. Thanks for watching.